Hello, I'm Sri from CBTU. CBTU presents a course on Big Data and Hadoop, Module Hadoop, Section HDFS Overview. Hadoop Distributed File System (HDFS) is based on Google File System (GFS) and provides a distributed file system that is designed to run on commodity hardware. It is highly fault tolerant and is designed to be deployed on low-cost hardware. It provides high throughput access to application data and is suitable for applications having large datasets. Some of the Hadoop features are open source, it is free and customizable, large datasets. HDFS can handle large amount of data using distributed file system, distributed storage and processing. Files stored across multiple machines in redundant fashion to protect data loss in case of hardware failure. Reliability. Hadoop is highly reliable. The built-in servers of Namenode and datanode help users to easily check the status of the cluster. High availability. HDFS also makes applications available to parallel processing. Hadoop is secure and provides file permissions and authentication. Hadoop is scalable, highly scalable, and it gives a touch of data locality for high performance. This is HDFS master-slave architecture. A HDFS cluster consists of a single name node, a master server that manages the file system namespace and regulates access to files by clients. And there can be number of data nodes which manage storage attached to the nodes that they run on. HDFS exposes a file system namespace and allows user data to be stored in files. Internally, the file is split into one or more blocks, and these blocks are stored in a set of data nodes. The name node executes operations and determines the mapping of blocks to data nodes. The data nodes are responsible for serving read and write requests from the file system's clients. Data nodes also perform block creation, deletion, and replication upon instruction from Namenode. Namenode or master server is installed on the commodity hardware that contains GNU or Linux operating system. Namenode manages the file system namespace, regulates the client's access to files, and executes file system operations such as renaming, closing, and opening files and directories. Datanode or slave node is installed on a commodity hardware having the GNU Linux operating system. Data nodes manage the data storage of the system, perform read-write operations on the file systems, perform operations such as block creation, deletion, and replication according to the instructions of the name node, the master server. The user data is stored in HDFS files. The data file is divided into one or more segments called blocks and stored in individual data nodes in HDFS files. A file is broken into small blocks of 128 MB. This is the default block size. And this is stored in distributed cluster for high availability and fault tolerance. Block is the minimum amount of data that can be read and write. Block size can be increased as per requirement. Blocks are replicated to 3 nodes by default, and HDFS is rack aware to avoid single point of failure and to provide high availability. HDFS file system is similar to traditional hierarchical file organization. A user or an application can create directories and store files inside these directories. Files can be modified, moved, or deleted. HDFS supports user quotas and access permissions. Namenode maintains the file system namespace, replication data, and metadata. This is about block replication. How block replication happens. HDFS stores large files across systems in a cluster. HDFS stores each file as a sequence of blocks. The blocks are replicated for fault tolerance. Block size and the number of replicas of a file are configurable. Namenode checks the replication of blocks. Namenode receives heartbeat and block report from each of the data nodes in the cluster. Heartbeat indicates liveliness of data node and block report contains a list of all blocks on a data node. Replicas are made as per rack awareness for data reliability, availability, and network bandwidth utilization. This is block 1 and this is replication of this one. This is block 4. These are the replications of the block 4. All HDFS communication protocols are layered on top of the TCP/IP protocol. A client establishes a connection to the configurable TCP port on the Namenode machine. It talks the client protocol with the Namenode. Data nodes talk to the Namenode using the data node protocol. A RPC abstraction wraps both client protocol and the data node protocol. Namenode never initiates any RPCs and it only responds to RPC requests issued by the data nodes or clients. The DFS admin command set is used for administering a HDFS cluster. We are going to watch these commands during demonstration. Thanks for watching.